Hi folks, today we're going to talk about the logarithmic parent function. So we just finished talking about the exponential parent function. And when I say finished, we're not really finished talking about it because it is very much connected to the logarithmic parent function. So logarithmic is going to be abbreviated to log. Okay, so logarithmic is abbreviated to log. The equation for the logarithmic parent function, first of all, it's important to understand that performing a logarithm is almost like an operation, like adding, subtracting, multiplying, dividing, raising to a power, things like that. It's almost like an operation. So the equation for the parent function is y equals log base b. So we put a little subscript b down here. It's not like a power, but it's kind of like down here. Log base b of x. So this is the equation. Now it doesn't make much sense now. It'll make a little bit more sense in the next lesson when we talk about switching between logarithmic and exponential form. But the table, even though we don't fully understand what this is yet, the table is easy to find. This b right here, this is the base. Just like b is the base when you have the exponential function. So y equals a base b to the power of x. So if we have a base of 2, in our exponential parent function and we pick some x values that are kind of around 0 like we do, we raise 2 to those exponents, those x values, and we get our y values. Now, one of the nice things, about a logarithmic parent function is that it happens to be the inverse of the exponential function. So if I can find the exponential parent function values for x and y, then I can perform an inverse, which means to switch x and y, and I'll have my logarithmic parent function table. So my x values were -2, -1, 0, 1, 2, 3 that were picked out. Now those are going to be my y values. -2, -1, 0, 1, 2, 3. And then for my exponential parent function, my y values used to be 1/4, 1/2, 1, 2, 4, 8. Now those y values are going to become my new x values. So 1/4, 1/2, 1, 2, 4, 8. And those make ordered pairs. So an example would be x and y, 1/4, -2. So those make ordered pairs. So I'm going to take those ordered pairs that are in my table and I'm going to go graph them. And you'll notice that there's already something on your graph. The exponential parent function with a base of 2 is already on your graph. And that's there because I want to show you graphically the inverse of the exponential parent function and how these two are related because they are inverses of each other. So I'm going to go graph my ordered pairs on my graph. So the point, there we go. So the point 1/4, -2. So just go over 1/4 and then down 2. Really close to that y-axis. 1/2, -1. So halfway and then down 1. 1, 0, right here. 2, 1, right here. 4, 2. 1, 2, 3, 4, up 2. And then 3, 8. 8, 3. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. So there's my logarithmic parent function with a base of 2. And let me see if I can make this a little bit nicer looking. I think that's as clear as I'm going to be able to get it. So our graph of the logarithmic parent function curves, right? It curves. It does seem to get very, very close to the y-axis without touching, and that's because it does. There is an asymptote right here. So this is y equals log base 2 of x. So that's our graph, and I want you to notice something. Let me get a different color. I want you to notice that this point right here is a reflection of this point over here. So we go half a distance to the dotted line and then half a distance past. Same thing here, half a distance to the dotted line, half a distance past. A diagonal distance of 1 to the dotted line, a diagonal distance of 1 past the dotted line. A diagonal distance of 1, 2 and a half, and then a diagonal distance after it of a half and 1 and 2, so the same distance. So because these are reflections of each other over the line y equals x, that solidifies that these two, the exponential parent function and the logarithmic parent function, are inverses. Because they are reflections over the line y equals x. So we have some key attributes that we want to discuss. The first for our key attributes is that these are inverses of each other. So the logarithmic parent function is the inverse of the exponential parent function. The x-intercept, well, if I look at my graph along the x-axis, that x-intercept is right here. And it's always going to be there for the parent function no matter the base. So this point is 1, 0. So x-intercept at 1, 0. Y-intercept. When I look at my graph along the y-axis, I see this graph starts to flatten out right here, so that means that there's an asymptote right here. There's an asymptote that goes through x equals 0, so there is no y-intercept. It's never going to cross the y-axis. The vertical asymptote is x equals 0. In the logarithmic parent function, there is no horizontal asymptote like there is in the exponential. So we've got a vertical asymptote now. The domain and the range are the last two things that we're going to discuss. So the domain from the left to the right. On the left, I see that it kind of stops right here. So it stops at x equals 0, but then it keeps going to the right. We've got an arrow right here, and it keeps going to the right. There's no asymptote right there. So my domain is going to be all x values that are this way, that are greater than 0. And then finally, for the range, from the bottom to the top, the bottom it just keeps going down, down, down. The top it keeps going up, up, up. And so that means that our range is all real numbers. So in summary, the logarithmic parent function is very much related to the exponential parent function that we've been dealing with for many, many days, many lessons, probably several weeks. And so the logarithmic parent function is y equals the log base b of x. It's the inverse of the exponential parent function.